I think we're good.
Awesome. Thanks so much, Paul. And you and Shirag and Steve definitely, like, you teed up. I love working with you guys on these presentations because we're all part of that same collaborative set of tools that are going to be coming from the cloud. Let's see, here we go. All right. Just a thumbs up, Paul. You can see my slides, right? Anybody? All right, awesome.
Affirm.
Awesome. Okay, so ladies and gentlemen, thank you all very much for this opportunity to talk about the Intelligent Edge within Azure. Just a quick background, my name is Jim Perkins. I spent 11 years on active duty in the Army. So a lot of the flavoring of the way I view the Edge comes from that. And in addition to working at Microsoft, I also spent some time after the Army working, as we like to say, across the lake at the other guys, where I got to do air gap cloud and edge with them as well. So I have a lot of experience in this, but I'm also just a customer because these products matter to me every day. And so that's I hope that's just going to establish some trust as we talk through this here. And when we're talking about the mission, everyone who's talked to you so far has really had a good tie to that mission. Starting with like a customer obsession perspective here, we recognize that there are many of our customers, especially in the government, US and worldwide, who need to use the cloud but need it in unique, under unique circumstances, unique requirements. And obviously, again, there's a lot of flavoring here from national security customers, but whether you're going to respond to Hurricane Katrina or a tsunami or an earthquake, like there's going to be degraded infrastructure. And so Azure Space, Azure 5G capabilities with edge computing is going to be the way you bring that high availability of communications and cloud connectivity out to where you are. Staying at that level, it's important to recognize that edge computing can actually occur at multiple levels. There's the strategic edge, which is still in what you think of like a traditional data center space, but maybe not in a full-scale data hall. Maybe it's just a server closet in a hardened building. And then as you step down to the operational level and tactical level, you're moving down this continuum of the network bandwidth that you have going down, the ruggedization and mobility requirements going up, and the form factor also going down because of the fact that that's the mission and the user that you're at. And the best way to show that is really to just jump into our product set here and to overlay it with like the full spectrum of edge. On the far left, you see our Azure Sphere microcontroller units, which are the best way to describe these is the perfect brownfield device to take some sort of industrial sensor. We like to use things, from being a Washington-based company talking about like Starbucks, but taking any other brownfield device that the government has, whether it's fleet vehicles or manufacturing or logistics, and then moving further up that scale. I'm sorry, I cut off that thought. Adding these microcontroller units, which are secure silicon, and then being able to collect IoT data streaming off of them, and then moving further up in the form factors to our IoT edge devices, our Azure Stack edge devices, which really bring high performance compute out to the edge. And then in this bucket that you see, it's the integrated platform. You have two paradigms here, which we're going to dive into more. One is cloud connected edge compute devices. And then the other side of this is essentially bringing a slice of the cloud out to you in that more common feeling. Many of our customers are familiar with Azure Stack Hub, especially in the government. And then obviously at the far end of it, you have the hyperscale cloud with all the services from IaaS, PaaS, and SaaS that you're very familiar with and enjoy. When we think of the traditional edge space in HVAC controlled or less austere environments, these are the missions. These are the products that we have in the Azure Stack portfolio. These can run disconnected, but they tend to need the HVAC and ruggedization you find in a hardened building. And these have been out for a few different for a few years now. With the Azure Stack Edge, this is a cloud connected one-use server with a NVIDIA T4, so you can bring local inferencing on whatever sensors you're pulling in data from. whether it's signals or electronics, data analytics for large fleet vehicle maintenance programs. Azure Stack HCI is our hyper-converged solution for managing a large scale of data center infrastructure. It's virtualization and storage all in one, but it's sold through a slightly different model. And then Azure Stack Hub is one of the most unique things that we make because of the fact that there's really no one else who is making a cloud native integrated system that can run fully disconnected. That if you have zero connectivity, if you never want to connect it, or even if you just have intermittent connectivity, this is a full rack scale unit that feels like the Azure cloud with a similar UI and API architecture. But where it starts to get more interesting is when we look into our rugged edge portfolio. And on the two devices on the left, for simplicity, let's just say small and medium, you have a 7-pound Azure Stack Edge Mini R, which has an onboard battery for 73 watt hours, but can also be tied to government standard BB2590 batteries. For those of you who are in the military or intelligence community, very familiar with those lithium-ion batteries. And when it's running on batteries, that onboard battery becomes like a uninterrupted power supply, so you can run this thing on mission for days or weeks just by hot swapping batteries. That's a 7-pound device with a 16-core chip and a video processing unit, so instead of a GPU, so it's better for battery performance. There's a 1 terabyte drive, and it's really an incredibly game-changing experience for bringing this out in a small rucksack or a day pack to be able to do local inferencing with this, whether it's drone video analysis or some of our other partners. You can imagine having just localized sensors where you're trying to get those inferences immediately. As you move up in the form factor, the Azure Stack Edge Pro R is a 1U device. There is a version of it for our defense customers that can be a 4U server, but this has an onboard NVIDIA T4, and obviously as the compute power goes up, the storage goes up, the power requirements also go up, so not battery, but definitely mobile and rugged. And then large and extra large, the Azure Stack Hub family of products are this second paradigm of a slice of the cloud that you brought out to you. So this has the feel of being its own micro region or an Azure availability zone where you are, so that even when your network bandwidth goes down, your IaaS and PaaS services can still run and can still get some updates, actually, which is a really differentiated and unique offering for us. And then the modular data center, which is only ready for the United States customers right now, is essentially multiple Azure Stack Hub pods inside it with all the HVAC and security controls, so you can run this with either multiple pods at different classification levels if that's your requirement, or compute optimized, storage optimized, wherever you need temporary data center infrastructure. This is particularly important in places where you wouldn't think. Most people's idea go to hostile environments, but actually if you're in a space constrained environment and you can move vehicles out of your parking lot to put space for this, you just expanded your data hall, and now your interior site in your building can now become office space for more workers. The overall story here, though, is that what you're getting at with all of these devices is the trust, security, and compliance you've known to expect from Microsoft. We've been in the business with the government for years now, so it's no surprise that we're already leaning forward with the highest bars for multiple layers of encryption in rest and at transit, tamper resistance, compliance. This isn't even the full list, but then most importantly, because these are hardware as a service devices, sanitization to NIST 800-88R1 standards to meet any customer's needs. And even for customers who don't trust sanitization and prefer to do disk destruction, we have options for that as well. But this is really the starting point of it. If you, we will always be there with trustworthy products in the edge space. The second piece of this that makes Azure cloud connected edge compute devices truly unique is the build once, deploy anywhere opportunity. You get an integrated DevSecOps experience. And this, when you're managing a litany of devices, it scales your capability, because instead of having to sideload all of your updates via a USB or an Ethernet connection individually, they can just be connected at whatever site, and you can deploy your patches via the portal centrally. And last but not least, this is going to be the overarching paradigm as we walk through a couple of user scenarios, but Shrag, Steve, and Paul highlighted this far better than I think I could in the couple of minutes that are remaining. The key thing here is, no matter what your connectivity scenario is, our edge compute devices will support your mission. And this is at one far end. If you are disconnected fully, whether by choice of your own or by an adversary's choice, these devices will run disconnected. And then as we move up from degraded or intermittent or latent connectivities, where you just have challenges that other systems are not designed for, because of the fact that the control plane is expecting to have a constant connectivity back to the cloud, our devices are designed to handle that. So the latency, the intermittent connectivity, these challenges are addressed. And most importantly, you have even more availability now by having Azure Space and 5G capabilities to make it an even more resilient communications architecture, so that the chance of you being fully denied or disconnected is lessened. And then obviously for our strategic edge capabilities, you can always run them in those permissive environments, which many of our customers in the unclassified government space are totally using these for, because surprise, surprise, most of the use cases are actually pretty traditional. It's the same things that our enterprise customers are looking at, which is logistics, local inferencing for sensors, maintenance, and other workloads that you want to have data sovereignty. You want to keep the data still on your site for a variety of reasons, but you still have some amount of connectivity back to the traditional hyperscale cloud or the internet. So this first example really showcases it the best. You can, using those disconnected edge devices, so an Azure Stack hub ruggedized, or a part of our connected back to our Azure cloud, you can have other sensors that some might be connected locally, and others that may be connected over SpaceX Starlink SATCOM. You can also have a device that's running and doing sensor analysis totally disconnected, but then for other ones, when they go in and out of connectivity, we've shown the full capability of everything we just talked about, not just words on a slide, but actually doing live analysis of water and fuel and other asset management capabilities in a variable connectivity environment. And then the flip side of it, being able to push updates out to those devices and have them wait to connect back to get those updates. Truly a game changer when you think of the variety of places that we're doing, especially national security work. Diving a little bit further into this is really pushing it out into the furthest part of the edge, and how this is changing the way we run missions or the way we respond to natural disasters. Again, this is sort of that same picture, but flipped. You have the hyperscale cloud on the left, and then we're working out further on the right to the end user. But when you start integrating our suite of sensors and integrated communications, you're creating what we like to refer to as hyper-enabled operators. And so they can have high command and control via a local radio network, a local 5G node, or even as needed via SATCOM. But they've also got not just the edge compute capability, but wearable sensors like HoloLens or other capabilities on tablets or smartphone devices, which is just changing the way that what would have normally required far more people out in dangerous or austere environments, you've now brought those same capabilities of cognitive services and translation out to those end users, which is just transformative. So the ISR inferencing, for those of you who really want to dive into this, I just want to take a moment here. It's important to understand how containerizing our different machine learning services are, how important that is for our edge compute workloads. And so I like to pull this up as a little bit of the architecture diagram so that the power users and engineers that might be on the call can really dive into this a little bit more and understand how containerized cognitive services are bringing these capabilities, and how the disconnected capability is really unique in this sense. So that's the upshot here. Not being able to gauge the feedback, I'm not going to spend too much time on this, but we have a very robust suite of containerized ML services, and the list is growing every day, as I'm sure you're all aware. And then lastly, this is the most traditional scenario that many of us can think of, but when you're pulling sensor data off of, again, fleet vehicles, aircraft, boats, or other local sensors like video cameras or radars, all of this data needs to get processed locally with an Azure Stack Edge device, but then you're continuing to push back those insights or backhaul that data through some other path when available to the disconnected cloud products. So this is just another this is just another way of laying this out in different use cases, and again highlighting the fact that the traditional communications channels of LAN and Ethernet are certainly a core part of the way we're going to be building these solutions for our customers, but not the only ones. And that these products are not simply replacing the hyperscale cloud that we have, but they're creating the high availability so that you're no longer having to choose between, a device that can only run disconnected or a device that is dependent on the cloud. These devices work where you work, and that's the best part about them. So, that is really all I've got, and I wanted to save some time for questions from this group. So I'm sure there were some in the chat, but by all means, Tina, Karina.
No, thank you so much for that. That was a great conversation. Thank you again to all the speakers. We are just looking through the Q&A to see if there's any questions. But we do have a lot of requests for the presentation, so I think there's a lot of interest in them. So let me look. So I think in just closing out, again, thank you for everyone attending tonight, and for the speakers. We will share the presentations in our LinkedIn group as we get kind of sign off of all the speakers, and we also post these videos on YouTube if you want to go back and check it out. So with that, please join us June 23rd for our next meetup, and you can find all our next meetups on the Meetup channel if you registered there. We often just post them also to the hashtag Azure Gov Meetup. So again, thank you to everybody who joined tonight. Hope you enjoy your evening, and we look forward to talking to you next time.